Welcome, everybody. I'm Angelo, and in this session, I will talk about the Internet over everything. Let's talk about IoT and Azure. But why is important to us to talk about IoT? The focus of this presentation is the Internet of Things because the use of Internet is now a commonplace with bits following all day long. And in this session, we will review the use of Azure Cloud technologies and how we can use those services with all of the gadgets, appliances, and mobile devices available to us. We will learn how to use Azure services with some of these devices and how the Internet of Things service can be managed. The first part of this presentation is focused on the IoT, but what IoT means. IoT obviously means Internet of Things and is a more intelligent way to collect data coming from every device that we can assume as things and bring this information to the cloud, to the internet. And in this scenario, we can find a lot of examples, from the simplest one that is the remote measuring temperature, or more complex, such as analysis on industrial machinery. And all this connection, all the moving of this data must be connected in a reliable and secure way to the cloud. But Microsoft has developed a custom version of its operating system called Windows 10 IoT in 3 editions. The lowest one is the Windows 10 IoT Core. IoT Core is thinking to test our solution in chip boards such as Raspberry, Minoboard, and so on. And why could be important develop on Windows 10 IoT Core? Because we have access to the universal Windows platform with our familiar API and with our familiar IDE, such as Visual Studio. We have other versions of Windows 10 IoT Core or Windows 10 IoT, such as IoT for mobile devices, that he has our familiar user experience with the shell provided by Windows 10, and on it we can run Windows 10 universal apps, drivers, and mobile application. On the more complex version of Windows 10 IoT is called for industry devices. In this version, we have the desktop shell, and we can run not only the universal Windows platform, but the Win32 application too. And so why use it? Because we have Visual Studio and the .NET framework running on the universal Windows platform. But we can use another way to run our C# code or our C# solution on the IoT devices. And this is .NET Core. With .NET Core, we can install all the tools, all the framework that we are confident with on the operating system based on Linux and Windows and Mac too. But the very important thing for an IoT developer is to have a board running and a Linux operating system, such as Ubuntu or such as Debian, Raspbian, and so on. Install on it .NET Core and execute all our .NET code, and in a way to recycle all our knowledge. But recently, Microsoft has presented another operating system, another way to access to the IoT world. This is called Azure Sphere. Azure Sphere is a new Microsoft operating system based on Linux. And this operating system has its focus on the security, on the efficiency, on the real-time processing unit, and is a very secure operating system. Because in an IoT solution, security is one of the most important values that we can have. But the first device that is designed to support Azure Sphere operating system is the MediaTek MT3620 that we can see at the bottom of the slide. But the security is a very important point because we cannot we have to not take care about hardware problem, hardware security issues such as meltdown, spectre, and so on, because the solutions are designed to be the most secure that you can imagine. Let's talk about the second part of this session that is focused on how to build an IoT solution on Azure. We have to think to an IoT solution in three fundamental parts. The first one is regards about the device connectivity. We have our board, our device, our sensor, or whatever you want, and we need to connect it in a secure way to the cloud. But to connect it, after connecting it, we have to process the data coming from this board that can be a temperature sensor, or can be industrial machinery, or another kind of solution. This data can be processed, analyzed, and managed by the cloud platform. And we can manage the device too. We can manage the device identity. We can manage the update of the operating system, of the solution, and so on. And the latest part is the final user architect. Is the latest part that we design in IoT solution, and it is linked to the final user. And we have the business connectivity process and the presentation layer. In this part, we realize a system that can show to the final user all the data elaborated or analyzed by the cloud platform. As many of us know, Azure has a very enormous number of services. In this slide, we can find a part of these services dedicated to IoT solution. As the first part, we have to manage the connectivity between the cloud and the devices. And we have services such as the IoT app and the Event app. As the second part, we have the stream process, and we have services on Azure such as the stream analytics that have to move all the data coming from the board to other services. Other services such as the storage one, such as SQL DB, storage DB, storage table, and so on. This data can be analyzed or in real time, or after collecting it in services such as EndUp, Academic Insight, or machine learning model. And we can provide some services to manage the identification of all devices. And so we can, in every moment, we can know which device is connected to our solution, what it's doing, and if we are running out of program. After this, we have the backend part that realizes the business logic of our solution. On the one of the latest part, we have the user experience presentation, and we have services such as app service or web app or mobile application that provide a more human understanding model to represent the data coming from an IoT solution, IoT devices, and so on. But see the connectivity devices part. I'm sorry. We have 4 ways to connect our IoT solution to a cloud service provider. We have the cloud gateway that is a direct connection between the device and the online service. And we can use this strategy when we have an IP capable devices can establish a secure connection across the network. And on the second way, we have a connection through the field gateway. The field gateway is another physical component that collect all the devices of our solution and connect all these devices to the cloud solution. Why we have to use it? We can use it in industrial scenario when we use high-specific connection protocols such as OPC or COAP5, or when we have a short-range connection between the devices such as Bluetooth or Zigbee, or when our device cannot establish itself a secure connection to our online solution using protocols, secure protocol connection, such as the TLS, or the SSL. At the third way, we have a custom cloud gateway. We can use the custom cloud gateway when the protocol that we want to use to connect our solution to the cloud is not supported natively by the cloud service provider of the cloud service. And we can use this service to transform the protocol before that he is connected to the cloud. The latest one is the union of field gateway and a custom gateway, and we can use it to use the best of the both technologies. And such as we have some devices connected to a field gateway that are connected by a custom VPN to the cloud gateway through the custom gateway. But the second part is the device identity and provisioning and store. At this part, we have a device identity authority. This authority stores all the information to validate the device, that because we cannot admit that one unknown devices could be connected to our network or to our service. We have another service that is called the device registry store. In this store are collected all the metadata related to the devices, such as the name, the version of the solution that is running, alerts such as there's an alert on the space, there's an alert on the connection, there is an update, and so on. But we can build some device provisioning API that are custom API that we create to allow to the device to present itself to the device identity provider to simplify our work. The device state store is another part of the architecture of an IoT solution. In this store, we can collect all the data about a device. At the other part is the stream processor. As a stream processor allows to us to transport the data without applying on it any kind of transformation, and bring this data to the other algorithms, other services that analyze and transform our data coming from the IoT solution. such as the temperature or such as other kind of data. And on this data, we can perform or a simple analysis, or we can perform a machine learning model to have a prediction of the future data that we can receive from the IoT solution. The other part is the storage one. In the storage, we can collect all the information came by the devices, and we can use those to analyze and to perform a machine learning model on this data. At the one of the latest parts, we have the app backend. We can assume the app backend such as the implementation of the business logic, the business model of our solution. And we can implement a layer abstraction of our devices or a group of devices to perform a more simple manage of the devices. We can manage the security of user and of devices. In this way, I can say, okay, you are connecting to the user experience part of my solution. You are the final user of the solution. You can see only some data, such as the chart of the status of some component. You are the IT admin of the solution. You can see more data than the latest, the final user. As the part of user experience, we can find one or more websites that show the information coming from the analytics or machine learning or from the storage. We can find web API to represent all the data coming from the solution to other applications such as desktop client, mobile client, and so on. This is an example of the user experience that we can perform running an IoT solution. We have at the left part of the presentation the engines of an plane, and on the right part we can find some chart about the single component of this solution, and we can find also other charts and other vital information of our solution. The very latest is the business integration and connection and gateway. In this part, we can think to connect our solution with other business services, such as CRM or ARP. We could have in our warehouse an IoT device to regulate the shipping status of the order. And this IoT solution is connected to a CRM to manage the warehouse. Let's talk with another services as a specifically linked to the IoT in Azure. I'm talking about the Azure IoT Suite. Azure IoT Suite is a collection of services running on Azure, and we have a pre-built model, customized solution, and we can easily integrate it in our existing business model, or we simply can test it or learn how to build an IoT solution. All the examples provided on GitHub about the IoT Suite can be our solution, a ready-to-go solution, and we can assume it as remote monitoring, predictive maintenance, and so on. The only thing you have to do to provide an example of how the Azure IoT suite example is working is an IoT, an Azure subscription, free or trial, or an enterprise subscription, and so on, and Visual Studio or other tools that you can find in the reference of the project uploaded on GitHub. But after this part of presentation, I want to introduce you to the demo that I will perform for this session. This is a very simple application of IoT solution. We can use Windows 10 IoT Core and one of the services of Azure, in this case one of the cognitive services, to remote controlling the light in a room or in other contexts. But let's start with the checklist to build this solution. We need a Raspberry or a board suitable with Windows 10 IoT Core, an internet connection, 2 LEDs, a breadboard, 4 jump wire, and 2 resistors. But first, we have to see how Windows 10 IoT Core nailed the GPIO pin on the Raspberry Pi. We have this list of the GPIO that we will use in the solution to connect to the LED or to other devices, such as a temperature reader or and so on. And we will connect the LED to this 4 pin, the 2 to give energy to the diode, and 2 to give the signal of switch on or switch off to the LED. This is an example provided by Fritzing to how to connect the LEDs and the resistor to the Raspberry. But first, let's talk about Azure Cognitive Services. Azure Cognitive Services is one of the part of Azure services in the context of artificial intelligence. We have some services to integrate in our solution some cognitive capabilities, such as the Vision API that can perform an image recognition or a photo recognition of what is happening in this picture. We have the speech recognition that is a cool solution to talk with our solution, our example, or what you have to do with your code, and such as we can do a simple sentence to our Raspberry and say, hey, switch off this light, do something, or do other good stuff. We have the language understanding API that provide the capability to our solution to really understand what we are saying. We have not to provide a couple of restricted sentences to realize our solution. But after I've trained our model, as we can see in the other slide, we can say other way to expose the same concept in our language that we have not predicted. We have the knowledge that is based on the being power to receive information about an argument. Or we have the search API that we can perform very useful research in our solution. But the Azure LUIS means language understanding intelligence service, and it can integrate a natural language understanding in our solution. As we can see in this demo, we can say, hey, switch on this, switch off this, in a very, very different way that we have not predicted. But how we can do to create this solution? Obviously, we have to run Visual Studio. In Visual Studio, a new UWP solution. We can open a blank Universal Windows app, and at the first part of the building process of this solution, we have to write some lines of code in the main page XAML class. We have this method to say to Windows 10 IoT Core, hey, I am on an IoT devices, and I want to perform something like a GPIO that I will call LED green pin or yellow LED or LED yellow pin, and I want to set this GPIO as the output, because we are coming out a signal from the Raspberry to the devices. In other cases, such as a remote temperature monitoring, we have to set it to GPIO pin driving mode with input, because it has the capability to read some information coming from this sensor. After this, we have to introduce in our code all the entity that we will provide on the Lewis solution, such as the entity that are the component that we want assume in our solution, such as the green LED and the yellow LED, and the entity, and or all the entity that are a combination of the yellow and the green one. After this, we have to create a new class that will parse the JSON coming from the Lewis and artificial intelligence application to see what is saying to us. To do this, we have to insert a new string with the connection string to the Lewis services, as you can see an example of this in this slide, and the parser of the JSON. But how we can set up a new Lewis solution? Simply, we have to go on lewis.aa and go to My Apps. After this, we have to create a new application. We have to provide the name of the solution and the language culture of our solution. The language culture can be selected. So we have to take care to take the best choice that for our solution. After this, we have to create the intents of our solution. In this case, we can assume the switch off intent, that is an intent to light off the lights. And after this, we have to say to Lewis, hey, I have think to 4, 5, 6 example to sentence to expose this concept in our language. The same thing we have to do to the other entity, to the other intents, the switch on one. After this, we have to create the entities of our solution. We can assume the entity to which is the thing that we want to control with this machine learning model. And we had to create the first one that is a simple type of entity, such as green light, another one that is the yellow light, and this is a simple type of entity. And we have to create all entities because we could have the capability to switch off both the lights of all the lights connected to this solution. And to do this, we have to select the composite type. This is an example to how build this entity model. At the left part of the presentation, we can find the green one with the entity type set as simple. And on the right part, we can find the composite one, all lights, that is composed by two child, the green light and the yellow light. After this, we have to insert in this model some way to identify this concept, such as green and other way to say green in our language. And we have to do the same with the yellow at the all lights. After this, we have to train our model so he can learn what we want to do with our solution and what we are saying in this text parsing. After this, we can test our solution further, integrate it in our Visual Studio Universal Windows platform, providing some example of sentences, and we can see the score that we can that can be provided with this sentence. After this is almost done because we have to publish the solution, and after this we receive a connection string, the connection endpoint that we have to insert in the parsing class of the JSON. But the JSON structure that is provided by the Lewis model is something like this. We have the query at the first line, and we can see what the Lewis services has understand. We have in a case of automation turn off. So, and at the third line, we have the score of this intent. At the second part, we have the score about the entities of this query. We can find at the entities part that the Lewis model has predicted that we can we want switch off all the lights, and it recognizes our intent using two keywords, all and lights. At the third part, we can see the composite event, the composite entities, that is all the lights. But let's see on Visual Studio how to implement this. Come on. As you can see, we are on Visual Studio, and we have built the main page example. We have built a simple user interface application with a text box where we can type the sentence to send to our IA LUIS services. At the second part, we have the GPIO initialization part with the definition of the pin when we connected the LEDs, and the analyzer 2 and the web client with the connection string to the LUIS endpoint. To do this, we have to connect to the Raspberry I'm sorry. We compile it. Distribution error. No. Why? I'm sorry, but I have a connection problem to my Raspberry Pi. I will try to reboot it. Windows Boot Manager. Choose your language setting and click Next. I'm trying to reboot my Raspberry. Oh, yeah, I am. You can see. Oh. Okay. Extend. Okay. I'm trying to connect again to my Raspberry Pi. I don't know why you don't want to connect. My devices. I reboot again. Cancel Windows installation disk. Choose your settings.
Yeah, Angela, we're not seeing the screen where you're working. We're seeing another screen.
Oh, I don't know why. I'm trying to.
We got this.
You can see my screen. I'm trying to connect to my Raspberry Pi, but it's not responding. Let's share again. Choose my screen. Okay, but okay, but yeah, I'm trying to connect to the device portal of my Raspberry Pi, but I can see to the other display connected to it that it wants to boot again. It was working until 10 minutes ago. Cool demo, very cool demo. I'm trying again to reboot it. Try again. IoT remote client. Okay. Probably we are. I really don't know why it's not responding. I'm sorry, but if you want to start
I think that's the nature of the beast.
in my website that you can find on the latest slide, you can see a post about this solution, and you can find a video with this solution running correctly. I'm sorry, folks.
Hey, that's okay. Right? This is the nature of live
Yeah.
presentations and live content, right? These things happen. And hey, like you said, for our folks that are interested, want to see a little bit more, there is a recorded video out there on the blog that you can check out. We'll make sure that we get that link from you, and we'll attach it to this video so that folks can follow up and learn more.
At this slide, you can find some contact detail about me, and this is my personal website, and I think that the post will be available in about 10 minutes.
Great.
That's perfect. Do we
There
have
are
any questions?
also the
Awesome.
All right, great stuff.
That was great stuff. That's the nature of an IoT presentation. Sometimes
Sometimes
the
it-
devices are finicky,
Right.
So
Cool. All right, so I'm not seeing any questions in the chat room right now. I see a lot of people saying thanks so much. Thanks for your efforts, inspiring us to dive more into IoT. And no judgment here. This is a very safe space. They're saying so. Very cool. Very polite from our friends in the chat room. So awesome. Oh my gosh, you have some great
you so
links
much.
there.
oh yeah, awesome links.
Thank you so much,
No
guys.
No worries.
All right.